In this video we're going to do a classic boat crossing a river problem. So let's kind of draw our river in here. There you go. That'll be the river. And we need our boat. A nice little boat. It's like a little sailboat. Ta-da. And we'll say the river is flowing. The river is flowing at about 4.5 meters per second to, we'll call it the east. So our boat will have, with a speed of 6 meters per second, we'll have it go north. Alright, so in order to do this problem here, we just want to set this up with vectors and kind of represent what's going on with the actual speeds here. So let's use a scale of 1 centimeter is 1 meter per second, and we'll have this way be north. Keep it simple. So my 4.5 meter second to the east river, I need to draw, I've already drawn it ahead of time here, we're going to draw this out at about 4.5 centimeters. .5 centimeters long. So our boat is going to have a velocity of 6 meters per second, so we have to draw the vector 6 centimeters long. And we need to line them up tip to tail. That's our rule for vectors. So we have them lined up here tip to tail. And this is 6 centimeters long to represent our 6 meters per second. So if you've drawn this 6 centimeters here and then tip to tail 4.5 centimeters here to the right on the paper, all you have to do then is draw from start to finish. So there's the start and there's the finish. So we can just draw in the resultant vector then from start to finish, and you can simply measure that with your ruler, and when you measure that you should get a measurement of about 7.5 centimeters. Should be about what you get from that, and that represents then a velocity of 7.5 meters per second. We're going north and east, so we say 7.5 meters per second northeast. Now, this particular velocity that we're looking at right here, this is the velocity that you see. I like to call this the velocity that you see. So if you're watching here and you're watching the boat go across the river at 6 meters per second, as the river flows at 4.5 meters per second, you would see along this path here, you would see the boat traveling 7.5 meters per second in this direction. You wouldn't see it going up, over, up, over, up, over, up, over. You would actually see the green arrow in terms of the motion, the velocity of the boat itself. Now, another way you can figure this out, maybe you don't have time to draw it out to scale, or you want to double check to make sure you've done this properly, is since this is a right triangle, this is your A, this is your B, and this is your C, you can use Pythagorean's theorem. A squared plus B squared equals C squared, and so we have 6 centimeters squared plus 4.5 centimeters squared equals our C squared. So we get 36 centimeters squared plus 20.25 centimeters squared equals C squared. And so that gives us a 56.25 centimeters squared equals c squared. So again, to find c, we need to unsquare. So we take the square root of both sides, and that gives us the 7.5 centimeters that we had in the first place when you measured it. So you can just draw it out to scale, measure it, that's fine. You can also use Pythagorean theorem to figure it out if you'd rather do that. Now let's say we know the distance across the river is 18 meters. So we got 18 meters across the river. We want to figure out how much time it takes to cross the river. Now, going across is in the northern direction, and so only the boat is actually moving in the northern direction. It doesn't matter what the boat does in the north direction or even south. The river is still going to flow at 4.5 meters per second. And the river could be a faster or slower river. The boat still moves at its 6 meters per second. So we can figure out the time to cross by just looking at the motion of the boat and knowing the distance in that northern direction across the river. So we want to find the time of something moving at constant velocity. That's just going to be distance divided by the speed. So our time is our 18 meters divided by 6 meters per second, and that gives us 3 seconds. It takes 3 seconds for it to cross the river. Now the next question would be, well then how far downstream does it go? Because I mean, this pink line right here shows the motion of the boat. If the boat started here, it wouldn't go straight across. We already know it's going to go along this green vector here. Our resultant vector is going to go along that direction. So it's going to end up somewhere over here downstream as opposed to straight across. So how far downstream? Well, that's just our distance, and our distance is going to be our speed times our time. But in this case we're talking about going downstream, so we're only concerned about the speed of the river here. Again, whatever the river speed is completely independent from the speed of the boat in its motion. So the distance will be the 4.5 meters per second of the river times the time of 3 seconds. We use the same time here because time is a scalar quantity. It's not affected by direction, and what's happening in the north is happening at the same time as the east. Again, this green arrow is what's happening for 3 seconds. So our distance ends up being 13.5 meters. Our seconds canceled out right there. And that's it. We figured out the time it takes to cross, about 3 seconds, and goes about 13.5 meters downstream.